Miroslav is ready, I would leave to him the floor. Miroslav Puskaricm is a member of HLRS, and he will illustrate to us the Orchestra project. So Miroslav, if you're there, please, the floor is yours.
Thank you very much, and thank you for the invitation. Yeah, I will now try to share my screen.
Yes, we see.
Okay, so oops, I'll go to the beginning. So I will give a brief overview of the case study in the Orchestra project using the federated data analysis approach. I will give a brief overview of the Orchestra project, talk a little bit about the data that is being collected, challenges, of course, which are present, and also of our IT architecture for the federated data analysis. So Orchestra is a project which has received funding from the Horizon 2020 program. The objective is to create a new pan-European cohort to rapidly advance the knowledge on the COVID-19 infections. So there are overall 37 partners from both from 15 both EU and non-EU countries, and one of the work packages are dedicated to the data management. So there are a couple of steps defined. A first step is to create and regularly update the data management plan. Then there is the data harmonization and standardization, so for the interoperability. Then there is the data protection and access policy assessment, which is of course important because we are dealing with the very sensitive information, the health data. Then there is the Orchestra platform design and implementation. So this is the IT and architecture and software stack needed for the data analysis and data storage. And then there is the integration of statistical analysis and modeling workflows, so to allow the implementation of different statistical workflows on this architecture. So there are 3 HPC centers involved. So these are Cineca from Italy, Cines from France, and HLRS from Germany. And the other partners are also Berlin Institute of Health, Helmholtz Center from Munich, and University of Verona. So challenges with the data management and data analysis. So this research data is considered highly sensitive because it includes information about individual health records of patients, such as symptoms or pre-existing conditions. Also data, it contains data from some laboratory samples such as blood, nasal swabs, and so on. And in some cases also genomic data. So the second challenge is that this data is distributed among various sites in different countries, which means that the data might exist in different formats, and also that the different legal regulation may exist. For example, despite the fact that the data that, for example, data providers are within the EU and hence the GDPR, but still there are different implementations of data protection regulation on every on a national level. And the last challenge is, of course, coordination with the 37 partners from 15 countries. And the project aims for data management that can balance the need for sharing data across borders for joint analysis, and also to ensure the protection of sensitive personal data. So this is like a basic example of a data set. And well, the data set is usually mentioned in the context of cohorts. So the cohorts in this case is a health data from a group of patients who share some defining characteristic, and those characteristics can be, for example, COVID positive patients, general population, fragile patients group such as organ transplant recipients, healthcare workers, and also some genomic data such as biobanking or virus host interactions. Well, the system developed for the Orchestra projects basically comprises 3 layers. So the first layer is the data providers. So the partners that, these are the partners that conduct the studies and that they hold the data, such as university hospitals. And then there are national hubs. So these are storage brokers in Italy, France, and Germany, so hosted by the HPC centers, who centralize the data and share it on a national level, only if it's allowed by the either data protection legislation or patient consent. So, and then the goal is to safely provide a harmonized and de-identified data to the data analysis tools. And then at the top, there is the Orchestra portal, which is deployed at Cineca. And it is envisioned as a pan-European portal for sharing the aggregated data. And it's also has a purpose of a central node for the data analysis. So it is, of course, very important to ensure scientific or good practices from the scientific data management and stewardship. So we, of course, follow these so-called FAIR data principles. So the data, to ensure findability, so the data stored or managed with the projects are can be described by metadata for findability, then accessibility, if of course allowed by the data protection legislation, which has to be proved. It is then ensured, so it is then possible to share anonymized data, so it's completely identified and cannot be identified again. Then there is also the possibility to share aggregated data and cohort statistics. And interoperability, well, here the already existing and well-accepted standards are used, such as GECKO, which is the German Corona consensus dataset. So it's a basis for electronic case report forms. Then there is the Health Level 7 FHIR standard for the machine-readable data formats, and then there's semantic interoperability using SNOMED CT collection of terminologies and LOINC, so for medical laboratory observations. And then there is a reusability, so data quality assurance, and also the information about analysis workflow can be provided. And then there is so the need for a federated data analysis. So well, it's interesting because it allows to collectively analyze data which are located at different locations. So then there are also cases where data cannot be moved either to a national hub or to the Orchestra portal due to the strict legal regulations, or if there is when there is a missing informed patient consent, or when the data is too big, which is usually present with the genomic data. And one of the further motivation is that this approach there is no need for a data centralization, no exchange of sensitive data, and the algorithms can be applied directly on the location where the data is located. So this is the like a brief overview of the architecture in the project. So here you can see, for example, these national hubs. They are there is, for example, in Italy, so hosted by this, which is hosted by Cineca. There is also additional software called RedCap, which is for acquiring data through the electronic case report forms, which is useful for the some specific type of data analysis, such as long-term sequelae or prospective studies. And then there is also some further steps are, of course, database or where the data is being stored. Then there is this harmonization part involved, some additional software for the federated data analysis or federated learning, which are installed both on the central portal and on the each national hub, as well as local, so-called local hub, which are hosted and administrated by the data providers.
Miroslav, sorry, just a
Yes.
couple of minutes. Then
Okay.
Thank you.
Yes, so this is one example of the architecture, which is, for example, hosted at HLRS. So the also well-accepted software is used, such as Opal, MongoDB for the database management system, R, program for statistical analysis, and perhaps one of the packages worth mentioning here is the Data Shield, which provide a very safe federated data analysis. So that means that completely anonymized information is being shared with the analyst. So thus, how the workflow looks like for importing data to the national hub is that the data from remote sources are de-identified there and ingested into the database management system, managed by also by the Opal software. And then these data are exposed to the R server, which is also hosted at the same location as the national hub. And yes, so these R data shield packages, they trigger analysis function on the data, collect the aggregated result, and send them back to the data analyst, or if they can be also combined with other data from other data providers or other analysis from the same workflow. And one of the analysis scenarios which are currently being developed and by the project is, for example, intervention effects on infection process and economy. Then there is impact of socioeconomic environmental factors, impact of the pandemic on socioeconomic factors. There is impact of delayed services to fragile population, relative costs, and modeling of vaccine trials and strategies. Yes, so this is basically, and the federated data analysis allows us to see, for example, what are the effects on different approaches to this COVID pandemic by the different countries, and to draw some conclusions out of it. And yes, that would be all from my side. Thank you very much for your attention.
Thank you very much, Miroslav. Then, of course, to the attendees, you can use the chat in case you have some questions for our speakers, so that eventually they can be back to you with answers, or eventually you can use the contacts that they leave in order to contact them later on. I'll then pass the floor to our next speakers. So we'll see here now 3 presentations from 3 different projects coming out from Horizon 2020, Big Data Value, Public-Private Partnership. So we will start with Rigo Wenning from the W3 Consortium, who will illustrate to us the MOSAICrOWN project. So Rigo, if you're there and ready, you can take the floor and start with your presentation. Thank you. We see the slides.
Okay, just putting on the camera so you can see me also. Hi, this will be very, very quick because 10 minutes is impossible to present the entire project because it's too complex. But I try to give you an idea. And if you have questions or if you are interested in the methods and the things we developed, either contact Anna. She will then put us in contact, or contact me directly under Rigo, RIGO, @w3.org. Okay, introduction to MOSAICrOWN. This caters to the data economy. It's creating a data market. We have more and more data coming from sensors, for smart cities, smart cars, from everywhere, and it's growing rapidly. Availability and sharing is essential for economy and society. We get insights, we get smarter. It's catering to the European data strategy, but as we have seen in the previous presentation, missing consent and all that can make data unusable. Then you need to aggregate, and the reconstruction attacks are so good that the more you aggregate, the less information you have in your data set. So the MOSAICrOWN vision is that we enable sharing and collaborative analytics in multi-owner scenarios, and while at the same time ensuring proper protection. And this is the overall architecture, where you see that treatment is done at ingestion time, at storage time, and at sharing time. So the objectives is to support a rich set of protection requirements, a data governance framework, a data wrapping, which is encryption and securing data, data sanitization, which is anonymization but also filtering, and effective exploitation in real-world operational environments by demonstrations. So the expected impact is GDPR compliance, made easy, very easy, by the way. Citizens' trust and UX is improved by privacy-aware transparency and control features across platforms. It provides new hooks for UX improvements, a lot of them. Value creation is improved and new opportunities. The approach is requirements capturing and representation, meaning this is the more or less in the ingestion. Because when you add policy by hand, it doesn't scale. So at the data collection time, normally the environment provides all kinds of information, and this is also the relation to high performance computing, because in order to tackle data protection, we need more data, not less, and we need policy information.
Rigo, sorry, we don't see the slides going through.
Oh,
can you just put them? I mean, restart presenting the slides. Let's see if it works.
Your screen sharing is paused, it says.
Yeah,
okay, but we don't see them moving.
Yeah.
Rigo. So now we see them moving.
Now we see them. Yeah, thank you.
Okay, so I show you. Did you see this one?
No, we only saw the first one.
Okay. So again, so that's data economy. Then this is the architecture where I say ingestion, storage, and sharing. Provide data governance framework. Expected impact. The approach. Here we are. The approach is requirements capturing, because in the environment we need to collect the data. We don't collect it by hand because it doesn't scale, and this really makes high performance computing a requirement, and this applies across the board from robotics to Industry 4.0 to everything. We then, in MOSAICrOWN, we have enforcement technologies to secure data in shared spaces. This is called wrapping. It's more or less encryption in some smart ways. and we have the enforcement phase of this in ingestion, storage, and analytics. So data owners need to have express their requirements and the constraints that come with data, and we do that by policies. And you can see from the right bottom that this is an annotation. We annotate data, and we use linked data to do so. And then the enforcement techniques is we provide wrapping. That means data is transformed and encrypted, and the data access only to certain parts of this information. And sanitization is filtering, but also anonymization. So you get data, you sanitize, and you don't get much of it back. So that means we do that at ingestion time because your environment is very rich, and sanitization allows you to filter the environmental data that you want to keep because it's relevant for policies. It allows you to encrypt certain data that you ingest and that you collect at ingestion time already. So it's only in an encrypted form in your data, and you need a certain special access to decrypt it. For example, Article 9 data, medical data that we just heard. Then we have storage. And then we have data sharing, where we can leverage. For the data sharing, we can leverage policy. We can decide which data types we share, which data types we need to sanitize, and which data types need to be encrypted, for example, in a multi-party computation scenario. Methodology is everything in MOSAICrOWN is modular and can be used gradually. That means every wrapping or sanitization or policy technology can be used modular. You don't need to have the entire MOSAICrOWN data market. It's just every tool is usable in isolation, and this makes it very much usable for your projects and for your high performance computing goals. So. And it works along different dimensions. It's the data governance framework that you can use, the wrapping or the sanitization. So the dimension of this problem are the policy, the enforcement, and the technologies and the enforcement phase, which is here nicely put into cubes that show the dimensions. So the policy has a reference metadata model, policy model language, and a policy management. The wrapping has basic techniques, enforcement mechanisms, controlled query execution, and other aspects. That data sanitization has mainly privacy metrics and risks. Data sanitization techniques mainly differential privacy and multi-party computation, and collaborative computation for sanitization. We had three use cases to demonstrate those techniques. The first one was intelligent connected vehicles by Dell in Cork in Ireland, a data market for financial data analytics by MasterCard, which is a credit card company, and for data sanitization, we had the cloud-based market for consumer analytics by SAP. It's mostly anonymization. So the first one is really exploring this data governance framework, and this was very successful because the intelligent vehicles ingested data. A user could give it some policies, and the fleet could give it. Fleet manager could give it some policies. Then it was in the governance framework, and depending on the permissions, analytics were done. Financial data was mostly about encryption of sensitive financial data and gradually opening up depending on what permissions as a financial manager and as an access to this market you have. And finally, data market for consumer analytics was for SAP. And as I said, it's mainly differential privacy in very smart ways. and I can tell more offline if you want. So the reusable results is this a really comprehensive method to gather your requirements, a data governance framework that is really working well with linked data and annotations, a policy model language, data wrapping, and data sanitization. And that's it from me. Thanks.
Thanks a lot, Rigo. Thank you very much. So we will pass rapidly then to our next speaker, Lukas Helminger from No Center. He will tell us about the safety project. So Lukas, the floor is yours. You've got 10 minutes, rough.
Perfect. You can see my slides?
Yeah.
Yeah. So thank you for having me, and especially Safety as a project to present to you. It was a rather small project, but in my opinion, very successful project. So my name is, as you said, Lukas Helminger. I'm a researcher at the No Center in the data security area. And in Safety, my responsibility was in work package 5, which was about the safe in Safety. So what all about this Safety? So the vision was twofold. It was a competitive Europe where individuals and companies are fully aware of the value of the data, but not only that, as we have seen already in the last project presented, it is very important as a European project that people and companies can feel safe to use their data, that is not misused, but used in a way that benefits the economy and also protects the rights from individuals. The Safety project consisted of 8 partners. So there were 3 research companies. No Center was the consortium lead, and then was also another company from another research center from Austria, RSA, which took the scientific lead, and EuroCAD from Barcelona, which was about data evaluation, what we'll see in the next slides. And then there were also 3 companies with Infineon, a semiconductor supplier, which provided industry data, and then Forthnet, now known as Nova, a telecommunications company, which provided personal data with the use case. And additionally, we had 2 universities, which one was KU Leuven, which was dealing with all the legal aspects that come up if you do data analytics on multiple parties. And then there were TU Delft, which they deal with the business models that arise, or new business models that arise from the possibilities, which we also saw in the last project, for example, from multi-party computation. And so the most visible outcome of the project is a personal data demonstrator. So this personal data demonstrator consists of 3 components which work together. So the first one is a multi-party computation-based protocol, more specifically a private set intersection protocol. This allows 2 companies or maybe 2 divisions of a company to work together on data sets and find common interests. For example, in Safety, we looked at where do, for example, 2 different companies have business together. So where are clients that they have, in which geographical region they have common customers, so they can maybe do some joint work there. But since multi-party computation only protects your data during the computation, you also need then somehow to verify that the output of the computation doesn't contain too sensitive information that you don't want to share. And so it was important also to have a component that analyzes this output and looks for de-anonymization risks. And the second pillar of Safety was that companies will be more aware what the data is really, what the value is of their data. And so we wanted to put a price tag on their data sets by sophisticated methods from algorithms, but also through some standard questions that we derived. We were not able to put really a price tag on it. This was a bit too ambitious, but it will, the outcome was a score on your data set, so that you give a feeling, every company, where they should work if their data set is already good enough to monitorize. And this is how the personal demonstrator looks like. So it is still available, at least a public version that is somehow a bit reduced because of data regulation, because of some rules that we don't have there, the actual data. But you can try it out. And if you're more interested, please just go to our website at safety-deed.eu. There you can find all the contacts that you maybe get an invitation for the demonstration of the private one, so with more capabilities. And also there you find the safety volume, which is a deliverable which summarizes all the outcomes and gives you the links to the more detailed deliverables. So now we had, this was the technology part. So we have this technology solution, but a lot of companies are not or cannot think in a way how to connect their data with outside sources. So they just lack the ability to think outside of their data ecospace, which they have in their company, and which other data could be useful for them. So the TU Delft lead the effort to make such tools for data-driven businesses, where you can now have a really hands-on approach with companies, and you can walk them through how to reach to a conclusion, which data you should exploit, with whom you should collaborate, and so on. And lastly, then, if a company decides, okay, we want to use MPC or some other technology that was mentioned, like differential privacy or federated learning, the next question often is, okay, how does this is reflected in the GDPR? So which consequences does it have if I use such a technology? And since there is no word mentioned in any regulation about MPC, federated learning, and even not encryption sometimes, this is very hard, and this has to be studied, and that's exactly what we've done. So give companies a bit of a feeling, if they use some of our technologies, which consequences do it have? Where do they benefit legally if they use, for example, multi-party computation? So to sum up, it was really an interdisciplinary approach focused on personal data and how you can monitorize it, but also how do you protect the individual rights granted through the general data protection. And yeah, that's the outcome of this project. Thank you.
Thank you, Lukas. Quite interesting your presentation as well, also because, yeah, one of the focus is exactly the one of being everybody confident in the way personal data are managed through the whole process of data processing. So thank you very much for your presentation. Again, if you have questions for our speakers, you can use the chat or eventually contact them separately when you prefer. So going now to the last project of this session. The project is Musketeer, and Weiss will from IBM will present it. So Gal, when you're ready, you can jump in and show your slides and take the floor. Thank you.
Yeah, thank you very much. I think I have a problem to share through Zoom. Oh. Maybe, Mattia, do you have my slides? Sorry about that.
Yes, I can share the screen for you. Give me 1 second.
Thank you very much, and sorry about that. Good morning, everyone. Weiss from IBM Research in Ireland. I'm delighted to be here today. I'm the coordinator of the Musketeer project, which is from the ICT 13, started in 2018 and ended late November 2021. You can go to the next slide, please. So we are 11 partners. No, the previous one, sorry about that. We're 11 partners across Europe as IBM, the coordinator, where we had the two important use cases, which I'm going to speak in a second. One of them in the manufacturing with mainly engineering, FCA item, which is Fiat Chrysler and Comau, and the other one with the health domain, which the group of hospital in Greece called Hygeia, and Biotronic. And then, of course, Imperial College London 3 and University 3 Madrid, where you can see the picture from Madrid before COVID, one of the last meetings that we had. The next slide, please. So what we actually had in mind when we planned, and actually what we did, is to have kind of a machine learning approach in a federated privacy preserving scenarios. So basically try, if you like, in a nutshell, to see how we can share knowledge about machine learning, but in a privacy preserving scenarios, so to keep the data secured. What we did in the project and what we aim and completed is to validate the federated privacy preserving machine learning platform and create them and provide secure, scalable, and privacy preserving analytics back to the premises. Can you go to the next slide, please? And the development of the methodology, we basically used GitHub from very early stage, and this is something that I can definitely recommend. So we had in the project, each of the partners had their own personal GitHub repository, but also one shared for the entire project. And this early integration efforts is very important, and those regular integration help a lot. We developed those 18 repositories on the GitHub, build open standards and products, and contribute to the open source community as a whole. And we made sure that the majority of the assets were shared through open source. And very important to have dedicated cloud instance per use case. So last in the topic is the Devops-based deployment, which is dedicated cloud instance per use case, as I said. Can you go to the next slide, please? And then in a very high level view, what we actually developed is, as you can see on the bottom, the premises. So the data user, which, for example, in the project, those are the Comau with the manufacturing data, Fiat Chrysler, and then the hospitals increase, which is the health data. So they hold the data in their premises and the aggregator, everything in the premises. What they share outside the premises, only the model, which goes to the IBM cloud, and then through different services could run the experiments, the machine learning, and return back the experiments. So we use through the IBM cloud, we use the RabbitMQ, the Cloud Object Store, Cloud Function, or the Kubernetes, and then all the information shared back without any type of data leaving the premises. Can you go to the next slide, please? And then how actually we secure the information that we're sharing. So we foresee some kind of attacks that we've been considered, like training time attacks, untrusted data sets, cloud secures, compromise the trains model, which are all being considered by the security partners, which is Imperial College London and IBM. And then during the project, we implemented those scenarios into the final assets. Go to the next slide, please. And another option is the evasion attacks through the execution time. So in Musketeer, we implemented mechanisms to detect malicious or faulty users that are then excluded from the federations of participants. Both poisonings and evasion attacks being tested during 2 hackathons during the project, both of them totally remote, where we ask some participants to try and break our shields, We also tested it among ourselves during the research and the development through the end of the project. Next slide, please. And then we, in the project, we developed 6 different privacy operation mode, those POMs, which looking on different encryptions and different models that we should test, depends according to the data, and each of them has totally different approach and use different methods. So the Musketeer machine learning library, this is the MML, provide variety of models and training algorithms under those different POMs, which are security models. The training data is always protected, either on premises or encrypted. And the protection of the resulting model changes across different POMs. Next slide, please. And then how we can choose for each type of data, how to define what the right POMs. So we had this very specific guide that you can check. Do I need to protect the model? Who get a trained model? Do the worker trust each other, avoid encryption or not? And can I run non-colluding crypto processor? And then we could know what type of POM to use, and then the machine learning library know what to choose and what type of algorithm to use. Next slide, please. And then as a summary, as we just completed the project and including the final review, the Musketeer project developed 5 open source tools using machine learning capabilities for different privacy operation modes, as I just articulated a minute ago, applying federated techniques while ensuring security and privacy in various flavors for different privacy operation modes. And these Musketeers tools can be used for future research and collaboration, but also for business purposes and improvement. And we saw it from the SMEs and other organizations in the project that actually planning to use it. If you want any more information, you can use the links below for the project website or my email address. Thank you very much.